Well, in our last video on quadratic functions, we're going to look at functions that are in this form, kind of the general form. We called the other form, the easier form, we called it the standard form. This is just the usual ax squared plus bx plus c. So how do you graph something like that? Almost identical. The only thing you need to worry about is what is the vertex here? There's no hk. So we don't instantly know the vertex until we do a little computation. Well, the x value is negative b over 2a. Okay, so you need to memorize that. Negative b over 2a. And then how do you get the y value? Well, whatever this value is, you just plug it into the function. So it's going to look complicated, but it's f of negative b over 2a. So if negative b over 2a happens to be 5, then the y value is whatever f of 5 is. Okay, so you need to memorize this. This is how you get the vertex of a quadratic that's written in this form. Other than that, everything is the same for graphing. So here we go. Here's an example. F of x is negative x squared plus 4x plus 1. So a is a negative 1, b is a 4, and c is a positive 1. We still use a to determine if it opens upward or downward. So it's going to open downward since a is less than 0. And the vertex is, well, we haven't computed that. Negative b over 2a is equal to negative 4 over 2 times a would be negative 2. So 2. So the vertex is, for starters, I'm going to do this. Okay, so this is our work for computing the vertex, negative b over 2a. What's f of 2? F of 2 is negative 2 squared, and remember that's not negative 2 being squared, it's just 2 being squared, and then there's a negative sign in front. There's no parentheses around the negative 2. So this will end up being negative 4. Okay, f of 2 plus 4 times 2 plus 1. That's equal to negative 4 plus 8 plus 1. That would be 9 minus 4, 5. So the vertex is 2, 5. All right, let's go ahead and plot that. Here's 2. And then we go 1, 2, 3, 4, 5. And it's going to open downward. And let's go ahead and we could plug in x values to obtain a few points if we wanted to. Let's get the x and y intercepts. That looks like a nice, they might be nice points for us. We'll see. Let's do the y-intercept first, which is f of 0. What is f of 0? It's pretty easy here. If x is a 0 here and it's a 0 here, then we just get 1. So 0, 1. Let's see. If x is a 0, we get a 1. And let me, sorry about that. I plotted the vertex incorrectly. It's 2. It's 2, 5. So that point should not be there. 2, 5. I'm not a very good one there. I'm going to go ahead and plot the axis of symmetry. So this gives us a second point right there. The mirror image. And I'm going to go ahead and I'm going to compute the x-intercepts, but in a minute. I wanted to show you that this graph, how does the graph shape compare to g of x equals x squared? How does it compare? Well, notice the coefficient of this is a negative 1. The negative shifts it downward, but it's exactly the same shape as this. It's not stretched because there's no, -2 or -4 or something like that in front. It's exactly the same shape. So you're going to get used to graphing that in different locations and shift and rotate it upside down. If you think of this as the vertex and you turned it upside down, to get another point, you'd go to the left one and down one. And you'd go to the, well, that is to the right, but let me just show. If we flip this upside down, from the vertex, you'd go left one, up one, and you'd go right one, up one. And you'd go left 2, up 4, and you go right 2, up 4, which represents really these 2 points, but we're upside down. So you're going to see that the shape of this graph looks exactly like the shape of f of x equals x squared, just shifted upside down, and the vertex was moved from 0, 0 up to here. All right, well, I've plotted it so we can see what the x-intercepts are, but notice it's not a nice number. It's not I should say it's not a nice integer whole number here, and it's not 0. It's in between 0 and -1 here. So how do we find those? You might be asked on an exam, give me exactly the x-intercepts. Well, you simply x-ints, you set this equal to 0, and you solve it using the quadratic formula when it's in this format. Okay, so I'm going to use the quadratic formula, and I'm going to use a, b, and c for the quadratic formula. And notice we expect to get something like -1/4, near that. It's not that, but something close to that, and maybe -4 or something like that for this one. So let's see, x is equal to -b plus or minus b squared is a 16 minus 4ac, all over 2a. Ooh, 2a is 2 times -1. Let me just put -2. -2 came from 2 times a, which is -1 times 2 is -2. Okay, well, notice what we get here when I break it into two. I like to break it into two fractions. -4 over -2 plus or minus that ugly radical over -2. And under the radical is 16. It's going to be plus because we have minus times a negative. So it'd be 16 plus 4 is 20. All right, I want to circle that just so I know exactly where we are. Now I'm going to simplify it. Okay, notice that this is really, in the quadratic formula, this is b over 2a, which is exactly where we got the x value of the vertex. This is 2 plus or minus something, and that makes perfect sense. Here's 2. It's going to be plus 2 point something, and this minus 2 point something. Let's see here. Radical 20 is radical 4 radical 5, which is 2 radical 5 over 2. And notice I'm going to take the negative sign off of that 2. Why am I allowed to do that in this one case? Because we already have the plus or minus here. So if it's a plus or a minus, it doesn't matter. We're covering both of them. The minus and negative would become the plus. The plus, the negative would become the minus. So the 2's cancel, and we get 2 plus radical 5. And radical 5, as we know, is just barely over radical 4. A little bit more than 2. So this, I'm going to put equals x-intercepts. which represent right there, which are represented on the graph right there, and right there. Okay, well that's the only example I'm going to do of a quadratic in this form, because it's basically exactly the same as the previous form, only difference being you have to compute the vertex in a different way. No matter what, if you can't figure out simply what the x-intercepts are, you're going to have to use the quadratic formula to find out exactly what they are. All right, so suppose you're given a quadratic in this form, just like we did. And suppose for some reason you forgot how to compute the vertex. And the only way you know how to do it is if it's in the other form, this form. How could you go from this form to this form? Well, all you'd have to do is complete the square. You can convert from that into that form by completing, let me start over. Completing the square. All right, well now we're just going to get a little bit theoretical here to finish up this video. Suppose we've got this form for a quadratic. It's a generic one. I'm not giving you a specific example. Since the vertex is, well, you need to memorize this, negative b over 2a, comma, f of negative b over 2a, we have the following. If a is positive, what does that mean? It means it opens upward. If it opens upward, does it have a minimum value or a maximum value? It has a minimum value. F has its minimum at x equal wherever the vertex is, negative b over 2a. And the minimum value, and that means the minimum value of the function, the minimum height, is whatever the y value is of that vertex, f of negative b over 2a. The vertex is very key. If you know the vertex and you know whether it opens upward or downward, you could graph it without knowing anything else and you'll probably get a lot of credit. You know, you may graph it too wide, you may graph it too narrow, but if you've got the vertex plotted correctly and it's opening the correct direction, you're going to get a lot of credit. Now, if a is less than 0, then it means it opens downward. So does it have a minimum value or a maximum value? It's got a highest value right there at the vertex. It has its maximum value. It has its maximum value at x equal negative b over 2a. And that maximum value is f of negative b over 2a. All right, our final two problems, we don't have to graph them. Let's just discuss these. What do we know about the graph of this parabola? Well, the vertex would be negative b over 2a. Oops, over 2a. Negative b over 2a. So since it's negative 7 over negative 6, I'm just going to put a plus sign there because negative over negative is positive. And then I am not going to plug it in. I'll let you do that if you like. F of 7 over 6 would be the y value of the vertex. Okay? And it opens downward. What is the axis of symmetry? It is the vertical line, x equals 7 over 6. I'm going to remind you that's a vertical line, because you have to have the x equals here to make it a vertical line. If you're asked for the axis of symmetry and you simply say 7/6, that's not answering the question. That is, 7/6 is not the equation of a line. This is the equation of a vertical line. And let's see, anything else we could ask about? Well, you could say, since it opens downward, it has a maximum value. Since it opens downward. The maximum value occurs when x is 7/6, and whatever this value is, again, I didn't want to plug in 7/6 into this function. You can do that on your own. Whatever this value is would be the maximum value of the graph, of the function, the tallest point. All right, this one is written in the nice form, the standard form. We like this form. Let me first put, since that 9 is positive, so opens upward. The vertex is -3/2, comma 1/3. That's the beauty of this form. The vertex is so easy to find. Remember what this is, if it were x minus 3/2, then we would have a positive 3/2. But x plus 3/2 gives us negative 3/2. And on this one, this would be the k in HK. You just take it with the sign, 1/3. So that's the vertex. It opens upward. So the axis of symmetry would be the line x equals -3/2. It's the vertical line. And since it opens upward, it would have a minimum value. And the minimum value would occur, where would it occur? Where x is equal to -3/2. And what would that, let me make sure I said that correctly. Since it's opening upward, it has a minimum value. The minimum value would occur at x equals -3, and the minimum value would be 1/3. So, one last question here. Does this graph have x-intercepts or not? It would not have x-intercepts because the lowest point on the graph is 1/3 and it opens upward. Here's the vertex and it opens upward.